So this is just a continuation of what we have been doing. We we learn how to find the function value for function of two or more variables, and now we'll focus our attention on how to draw the graph, particularly how to plot a points in 3 dimension. Okay, how to plot a point for function of two variable. When we say function of two variable, so we're talking about a 3-dimensional rectangular coordinate system. So we will learn how to plot the points, and then we will learn how to plot the plane, simple um, simple plane equations, how to draw that. So for example, look at example 6. Plot these points 0, 3, 4. P, the location of P is X is 0, Y is 3, and Z is 4. You know that in 3 dimension, this is your X. Let me draw here. X, Y, and Z. So similar to 2-dimensional rectangular coordinate system, so you have positive X this side, okay, and then negative X this side, right? Positive Y up, and then negative Y is down. We know this. And this one is called first quadrant, which means X is positive and Y is also positive. This is called second quadrant. This one is third quadrant, and this one is fourth quadrant. So there are 4 quadrants in 2 dimension. In the same manner, in 3 dimension, you will have octant, 8 of those part, okay? 8 of those part. So that's why it is called octant. And X is positive on this side and X is negative on this side. So this side, negative X. Y is positive on that side, Y is negative on this side. So this is negative Y. And Z positive on, above, and Z is negative below. Just keep that in mind. Now, if you want to plot point P, P is 0, 3, 4. So X is 0. Let me just make a 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So in order to plot point P, X is 0 means it's right there. And Y is 3 and Z is 4. Y is 3. 1, 2, 3, and Z is 4. So 1, 2, 3, 4. So that will be the point. So this is the point. Okay. X is 0, Y is 3, and Z is 4. So this is your point P, 0, 3, and 4. Let us plot point Q, 2, 0, 4. X is positive 2, which is here, that's positive 2 here. And then your Y is 0, and Z is 4. So Z is 1, 2, 3, 4. So you draw a parallel to this line and you go there. So that's your Z. Okay. Notice that this line and this line are parallel. I'm drawing that parallel there. So this point right here is Q, which is 2, 0, and 4. And in the same way, you can draw the other points. R is 1, 4, 0. X is 1. Y is 4. Okay, let us draw that as well. X is 1, positive 1. y is 4. So 1, 2, 3, 4. So this will be, when I draw the parallel line to this one and this one parallel, so this is the point. Z is 0, therefore this is the point, okay? This is your R, 1, 4, 0. So that's how we plot the points. Now, how do we draw a very simple graph of plane? Let's look at that. I trust that you can do this S and T yourself. Now let's look at how to draw a plane in 3D. So example 7, draw a graph of the following plane, z equals to 2. So what it means is, you know that drawing graph in 3D is not that easy, and it's not that clear cut as in the case of 2-dimension, but we'll try our best, okay? So therefore, in order to draw a nice graph in 3D, we generally use computer software, but we'll try our best to draw the graph in 3D. In example 7, we want to draw the graph of the plane z equals to 2. In part A, z equals to 2. What it means is z is fixed, x and y could be any value. We don't know. It could be anything. Just the condition here is that just the, value of z is given, which is 2 always. So to draw the graph, what you can do is, again, in the same manner, this is your x, y, and z. So z is 2 means 1, 2. So this is fixed. Okay, this is fixed. But x and y could be anything. It could be anything. So you can say that this is one example of the plane. So that means it is a plane parallel to x and y plane. So imagine that you are in a room, okay? You are in a room in your house, and x and y axis are actually the 2 dimension of your room, and z is the dimension which is going towards the ceiling. Now here what you're doing is, imagine that you have a line going at 2 feet there in the wall, okay? And so this one is parallel to the xy plane, and it's kind of difficult to draw the graph, but you can say that z is fixed, which is 2, and x and y could be anything. So this is a plane which is parallel to xy plane. In the same way, y equals to 3 means it's a plane parallel to xz plane. So this is a plane parallel to xy plane. So this is parallel to, it's kind of, if your ceiling is, let's say, 2 meters, then the ceiling and the floor, this one is your ceiling actually. Okay, ceiling and floor are parallel. So the plane that I'm drawing here in A is actually the plane of a ceiling. And now part B, if you want to draw a graph for y equals to 3 in 3D, so this is clearly parallel to xy plane, sorry, xz plane. This is your x, this is your y, and this is your z. So here y is fixed. 1, 2, 3, y is fixed. Okay, x and z can take any value. So what we do is, let us consider that this is our plane. Okay, random, just this one. In this case, one thing, please remember, when I say plane, it is not fixed. The fixed side is this one. So here it can go up to infinity. This can go up to infinity. This also can go up to infinity. And it's not possible for me to go all the way up to infinity. So I just give you one sample here, sample plane. In this case also the same. So Z is fixed, but this side can go up to infinity, this side can go up to infinity, this side can go up to infinity. Okay, so that's the plane is just extending up to infinity. The only condition in part A is Z is fixed, in part B is this Y is fixed. That's it. In the same manner, you can draw the plane for part C. Now the question is, how can we draw a plane if it is not that simple plane which are parallel to one of the coordinate planes? Something like if we are given 4x plus 2y plus 3y, 4x plus 2y plus 3z equals to 24, how do we draw the graph in the first octant? We just want to draw the graph in the first octant portion only. So how we do that is, in this case, we want to draw, we want to find the intercept first. Okay, let us find the intercept. For this, first find x, y, z intercept. How do we find x-intercept? Any idea? X-intercept means if this is a plane, 3D graph, x, y, z. X-intercept means it could be anything. So in x-axis, any point on the x-axis, the y and z value will be 0, right? Any point on the x-axis, y and z value is 0. So for that, you will see for x-intercept, set y equal to 0 equal to z and solve. That means 4x plus 2y is 0 plus 3z is 0 equals 24. This is going to give you x equals 6. So one of the point is x is 6, y is 0, z is 0. That's your one point. That's your x-intercept. In the same manner, I want you to calculate y-intercept and z-intercept, please. For y-intercept on the y-axis, what happens? Which value are 0? And for the z-intercept, which value are 0? And calculate and let me know what will be your point there. So for y-intercept, on the y-axis, x and z value will be 0. So therefore, 4x is 0 plus 2y plus 3 times 0 equals to 24 gives me y equals to 12. So the point will be 0, 12, and 0. Now for z-intercept, we need to set x equal to 0 equals to y. So that's going to give me 4 times 0 plus 2 times 0 plus 3 times z equals 24, and that's going to give me z equals to 8. So the point is 0, 0, and 8. And let us draw those points in the graph. So this is my x, y, and z. All right. So let us plot those points. The first point, x-intercept is 600. Suppose 6 is here. Okay, this is 600. And y-intercept is 0 to 12. So let's say this is 12. Y-intercept is 12. And z-intercept is 8. So let's say this is your 8. Now, to draw the plane in the first octant, what you need to do is just join those points. That's it in the first octant. So this graphs right here is the equation of the plane given by that equation. Okay, this is the plane, this is the graph for equation 4x plus 2y plus 3z equals 24. Okay, that's how we draw the graph in the first octant. Any questions so far? Now let's look at distance between 2 points. And I want to take you to high school for just for 1 minute, because you need to recall one formula from high school. In your high school, what you learn is, let's say this is your x and y axis, and suppose here is a point, let's say P, and here is another point, let's say Q. P is given by x1, y1, and Q is given by x2, y2. So if you want to find the distance between these 2 points, P and Q, PQ, and you know that the distance will be x2 minus x1 square plus y2 minus y1 square. Do you still remember that formula? Basically, how you do that is that you make a right angle triangle, and this guy is x2 minus x1, and this one is y2 minus y1. So using the Pythagoras theorem, that's what you're gonna get. It's for the 2 dimension. Now for the 3 dimension, suppose you are given 2 points in 3D, x, y, and z. For example, you have P there and you have Q there. So P is, let's say, x1, y1, z1, and Q is x2, y2, and z2. So the distance between P and Q is given by square root x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. Same formula can be extended further, no issue there. Okay, so these are the 2 formula that you may want to remember. Now I want you to try example 9 on your own. Find the distance between points A and B. So your A is, let's say, this is your x1, y1, and z1, and this is your x2, y2, and z2. So find the distance between A and B. Distance between A and B is given by D equals square root x2 minus x1 square. We know the formula, plus y2 minus y1 square plus z2 minus z1 square. And then you can calculate this. Somebody already got the answer there. Yeah. So that's going to be square root 7 minus 1 square plus 5 minus 2 square plus negative 3 minus 3 square equals, is that 9, you said? Okay. Yeah, so many of you got 9 there in the chat box, and I trust that it is the right answer because it is very difficult to get the same wrong answer. Anyway, so the distance between A and B is 9. That's how we can calculate. Okay. Now let's look at equation of a sphere. Now in your high school, you learn that equation of a circle is given by, again, I want to take you to high school just for 1 minute, if you don't mind, okay? And in high school, you learn the equation of a circle. What is a circle? Well, if you have two-dimensional figure here, and let us suppose that this a random circle is somewhere there, okay? Let's say a random circle is somewhere there, let's say. And this point is, let's say, A and B. Okay, that is the center. And the radius is R, let's say. So we're talking about 2D because circle forms in 2D, two dimension. Now, what is the equation of a circle? Well, you know that from high school, it is equation of circle is given by, we just consider one random point, x minus a square. X and y is just a point on the circle, so x minus a square plus y minus b square equals r square. That is the equation of a circle. Now, let's talk about 3 dimension now. Okay, so when we talk about 3 dimension, that circle will convert into a sphere. It's like a ball, you know, the soccer ball. Okay, it's just like that. So equation of a sphere is given by, same thing. Let's say a sphere is somewhere here. Okay, this is a ball, let's say, with center at A, B, C is the center and radius is R. Then equation of a sphere can be written as x minus a square plus y minus b square plus z minus c square equals r square. That is the equation of a sphere. Okay, in 2D and 3D, sphere will be in 3D. Now let's try example 10. Write the equation of a sphere with center 2, negative 3, 4, and radius 3. So center of a square is center of a sphere is represented by A, B, and C, and you know the formula. So equation of a sphere is given by x minus a square plus y minus b square plus z minus c square equals r square. Substitute the value, which means x minus a is 2 square plus y minus, this will be positive 3, y plus 3 square plus z minus 4 square equals r square, which is 3 square, which is 9. That's it. Any questions so far? So if we are given a center of a sphere and the radius, you can find the equation of a sphere easily. Once again, the goal of this course is to apply, apply the concept of calculus to solve real-world problems from business and economics. So we don't go into much details about the graphical part of this function of two variable. I'm just giving you a simple, basic idea from graphical perspective for this function of two variable, but we don't go into detail. Okay, just a basic idea. Now this there is another important concept called level curves and contour plots. What I would like you to do is, I have provided you in my lecture note, I have provided you these two videos, and I want you to watch this video by yourself, just for your knowledge. Again, the goal of this course is to apply the concept to solve real world problems. So at this moment, we will not do this part, but if we have time, maybe before the final exam, we'll work into into the level curves at that time. Right now, I just leave it to you to watch the video and try working on this example too well. Okay. And with this basic idea of function of two variable, we're gonna start working on the calculus of function of two or more variable. So we will learn how to find the derivative of function of two or more variable in our next class.